All right, guys, this is chapter 26, checkpoint number 2. What's important to note here is the definitions of all these things. The definition of I, right, or of our current is simply the direction in which positive charge is flowing. What that means is the direction in which charge carriers are moving. And what is a positive charge carrier? Well, you can think of them as kind of the opposite of electrons, but essentially what they are is the vacancy of an electron from an atom or on an atom, right? So when an electron leaves an atom, then all of a sudden that atom becomes positively charged, right? So we have this atom here, right? And when we have these electrons around it, right, what happens is if one of these atoms go away, well, then all of a sudden this is positively charged, right? And it's essentially like the shifting of these electrons in which this vacancy spot, right, this like vacancy spot that's causing the atom to be positive is like basically moving, right? It's like the direction in which this vacancy spot is moving, right? And so that is what the positive charge carriers are. It's simply a vacancy of an electron that should be there, but because it's not there, now we have a positive atom, right? And so so these positive charge carriers are moving in the direction opposite to that of electrons. So in this picture, right, the electrons are moving to the left, right? And we can see that through here, right? These electrons are moving to the left, which means the positive charge carriers are moving to the right, which suggests that I, right, is going to the right, right? Now, it's an important distinction to know that I, right, it's a scalar, right? It's not a vector. So with that being said, the next thing we're looking for, the current density, J, right? The current density J is defined as being the actual direction in which the positive charge carriers are going. So that's going this way. Whoops. That's going this way, right? Now, if the electrons are going this way, right, and the positive charge carriers, right, are going to the right, then that means there has to be a positive over here, and there's going to be a negative over here, right? And for this to be the case, then that suggests that we have our electric fields going this way, right? Which means that if the E fields are going this way, the final answer to this is for A, it's going right, B, right, and C, right.